Hey guys, today we're going to continue doing polar graphs, and today we're going to talk about how you can deal with them without using a calculator. So the first thing we're going to look at are some equations, and the first thing we need to figure out is what type of graph is this. And so hopefully on yesterday's Desmos activity it kind of helped you see what these graphs are going to look like, but I know if I have anything that just has a single trig function with no coefficient on the inside, I'm going to have a circle. And so this guy is going to be a circle that's going to be on the x-axis, so it's going to be a horizontal circle. And this negative tells me that it's going to be flip-flopped. And so it's going to flip over and be over on the negative part of my axis. So we could say that it was reflected. So that was all kind of stuff I knew based on the graph itself. Now, I actually want to go through, though, and graph this and figure out where the points lie exactly on this polar graph. So in order to do that, I'm going to make a table. And when I used to make a table, I used to make an XY table. But now we know that our coordinates are in r theta form. So I'm going to make an r theta table. Now the weird thing about this is that I know theta values more than I know radius values. So instead of starting on your left side, you're actually starting over here on your theta side. So if you wanted to flip-flop your positions, that would be a-okay, because I know these important values of my trig functions. And so if I plug these into this expression over here, it's going to be pretty straightforward for me because I know all of these answers should either just be 0 or 1 or -1. This is just the OIO chart. So if I plug in 0 into this equation for theta, I know that cosine would be 1, and 1 times -4 is going to get me -4. Same thing, I'm plugging pi over 2. That's going to, cosine of pi over 2 is 0, so anything times 0 is 0. Cosine of pi is -1, and -1 times -4 is just +4. And then cosine of 3 pi over 2 is just going to be 0 again. So now I have some points that I can plot, and I can kind of decide how this is going to look on my graph. The first thing is that at the angle 0, I'm going to have a radius of -4. So if I went over to this angle of 0, remember if you have a negative r, you actually go backwards. So I'm going to be over here 1, 2, 3, 4. So I'm going to be like 180 degrees away from it, but I'm going to be on that same line. Okay, pi over 2, this line is going to be at 0, a radius of 0. Pi and then 4. So pi, 4, I already have that point. That's okay. And then 3 pi over 2, 0 right here. So I kind of saw the order that got graphed in. So I started over here, and then I went over here, and then so I made this circle. Well, I tried to make a circle. Well, it's still kind of not very circly, but there's your circle. And I graphed points so I could see what direction it was going. Okay, so that's the idea if you have something like a circle. Now let's look at one of the more tricky kinds of graphs, like for instance this guy. So the first question that you're going to ask yourself is, what kind of graph is this? What shape do I expect this to make? And if you remember, this is the a value is the one you're adding, and the b value is the one in front of the trig function. So this graph has an a that's less than the b value. And if you remember from yesterday, that's going to be a limacon. I guess it would be from today. It's a limacon, and it's going to have a loop in it based on the criteria here. So I'm going to have a limacon with the loop, and it's going to be on the y-axis because of the sign. So let's figure out what shape that's going to make. And again, I'm just going to make my r theta table, and I'm going to fill in the thetas that I know. I'm just going to plug in values and see what happens. So if I plug in 0 here, the sign of 0 is 0, and then add 2 to that, so my value would be 2. Okay, sine of pi over 2 is just +1, so 1 times 4 is 4, plus 2 is 6. Sine of pi is 0 again, so I would be back at 2. And then finally, if I have sine of 3 pi over 2, that gives me -1. So I have -1 times 4 plus 2, which would get me into a -2. So now I have some points that I can plot. So I have at the angle 0, I'm going to go out to a radius of 2. At the angle pi over 2, I'm going to go out to a radius of 6. So 1, 2, 3, 4, 5, 6. Oop, right at the top. Got lucky there. Okay, at the angle pi, I'm going to go out 2. And then at the angle 3 pi over 2, I'm going to go out -2. So remember, I'm going to look at this angle, but then I'm going to go backwards 2. And so since I know that this is a limacon with a loop that makes that little like lima beanie type shape, and then it's going to go up into there and then back around. So there's the picture that I got from this guy. Now they're also going to ask you things like, where is this loop? What's happening here? How do I know where the loop begins? Well, if you look right here graphically on this thing, this loop starts when your r is equal to theta. So, sorry, your r is equal to 0. So we can see right there that that's one of the points where it's going to be. So what I'm looking for here is the first time that r is equal to 0. So I'm just going to plug it into the equation. I have 0 equals 2 plus 4 sine of theta, and this is just an equation that we need to solve for theta. So I'd subtract 2 and divide by 4, which would get me the equivalent of -1/2. And so then I could go ahead and just take the inverse sine of both sides to figure out what that theta value would be. And so this is where knowing those exact values and those inverse trig functions is going to come in a lot handy, because when I'm looking here, I'm going to have that triangle that I draw with the negative opposite and the hypotenuse, and this would be √3 then using Pythagorean, so I know that this is a 30-degree angle. But if I'm trying to get all the way around over there, that would actually be 210 or 7 pi over 6 radians. So the first time that that loop where it hit r is equal to 0 is 7 pi over 6. Similarly, if you wanted to figure out where the loop ended, that's the next time that r is equal to 0, because it's got to come up and then it goes back down. And so if I'm thinking about the next time that sine is negative, because remember all students take calculus, it's going to be over here in this quadrant with the same reference angle. So if I go another set of angles, that would just give me 11 pi over 6. Okay, so again, it's just looking at the graph, deciding what important point you're looking at. Okay, the last type of graph we're going to see are these guys, which remember, if there is a coefficient inside your trig function, you're going to have a rose. And the roses get a little bit tricky, because if you have an even coefficient here, then we're going to have times 2 of those. So since it's even in there, it's going to have 4 petals, not just 2 petals, it's going to have 4 petals. And again, when you graph this, you want to make yourself a little r theta chart. Now, here's the big issue I see, and that's if this is 2 theta, my regular way of doing this is going to be confusing, where I just plug in a theta, but it's timesing by 2, blah, 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 blah. So what I'm going to do is call this angle 2 theta. So my regular angles that I like to plug in, I'm just going to make that be that entire 2 theta. And I'm going to go about doing this the exact way that I used to do it. Again, I'm just plugging into the inside here, and I'm going to write what I get. So I know that the sine of 0 is going to be 0. The sine of pi over 2 is 1. The sine of pi is 0. And the sine of 3 pi over 2 is -1. Okay, but now I want to graph this in terms of theta. So I'm going to go ahead and just make another column on my chart that says theta. And I'm going to divide all of the angles I just plugged in by 2. So I divided 0 by 2, I got 0. Divide pi over 2 by 2, I get pi over 4. Divide pi by 2, I get pi over 2. Divide 3 pi over 2 by 2, and I'd get 3 pi over 4. Okay, so again, I just manipulated my table in a way that made it make sense to me. So that way I could plug in my regular values and not have to worry about multiplying the angles by 2 or anything. I went backwards and fixed it later. So now when I'm graphing this, I know that I'm actually going to be looking at the chart right here. So I'm going to have, at the angle 0, I have 0 radius. At the angle pi over 4, which is in between these two, I'm going to have a radius of 1. This will be really tiny. Then 0, it's at pi over 2, it's 0 again. And then at 3 pi over 4 over here, it's going to be a -1. And so it's going to be going backwards again. So you kind of get an idea of the shape here. Remember, I'm trying to make 4 petals on this guy, and those are going to be the ends of the petals. And so I want it to be symmetric across the Y. Oh, I tried really hard and I messed those last ones up. But I can see that the ends of the petals are every pi over 4. So then, if they ask you something like where do the petals begin and end, I have the same process that I did before, where I'm going to just plug in 0 because the petals are going to start and end whenever they hit that pole. So 0 equals the sine of 2 theta. So since I have my trig function isolated, I can just take the inverse of both sides. And I know that the inverse sine of 0, what angle gives me that ratio of 0, would be 0 degrees or radians, or at pi. And that equals to 2 theta. So then I just go ahead and divide all the answers I got by 2, and I would know that this is going to happen every pi over 2 radians. And we could kind of see that happening here. It was 0 at 0, 0 at pi over 2. It probably would have been 0 at pi again. So every pi over 2 radians is when those, I guess I should write the petals are going to start and end. Okay? And if you feel comfortable at this point, you can totally stop watching the video. I'm just going to work through one more of these just to kind of help you see these roses a little bit more clearly. So this is last optional example. So if I look at this one, again, you're going to have, it's just a singular trig function with some sort of coefficient on the inside. And so I know that that's a rose. And because this is odd, it's only going to have that number of petals. And since this is a cosine, also, we're going to see how this looks a little bit different than the sine ones. So I'm going to do the same process here. I'm going to have an R column, and I'm also just going to use whatever was inside here, so 3 theta. I want to plug in my easy values and not have to worry about that 3 right away. Okay, and so once I plug this in, if I take the cosine of 0, I get 1, and I times that by 5, so that's 5. Cosine of pi over 2 is 0, so 0 times 5 is still 0. Cosine of pi is negative 1 times 5 is negative 5. And then cosine of 3 pi over 2 is 0. And then again, I've got to follow that same process where I go ahead and I just want to find out what the real theta is. So divide each of these angles by 3. That would get me 0. That would get me pi over 2 divided by 3 is pi over 6. Pi over 3. And 3 pi over 2 divided by 3 would just get me pi over 2. Now I can just graph these angles. So I'm going to have 0, 5. So at the angle 0, I'm going to go out 1, 2, 3, 4, 5. Okay, at pi over 6, it's 0. So at this angle, it's 0. At pi over 3, right here, it's going to be negative 5. So remember, I'm going to have to go backwards. 1, 2, 3, 4, 5. And then at 0, or pi over 2, it's 0 again. And so if I was to try to connect these dots or continue this pattern on, we would have an idea that it's probably over here at 2 pi over 3. And you would see that that would happen again. And so when I connect my dots, I'm trying to make a rose with 3 petals. And again, they're symmetric over the x-axis or over this horizontal axis because it's a cosine function. Okay? And so there's my picture. They're all length 5. That makes sense. I have a rose with 3 petals. And again, if you're looking for where the petals begin and end, you're just figuring out when does it hit that pole. So we're going to have 0 equals to 5 cosine of 3 theta. I'm going to go ahead, and this one I would divide both sides by 5, which doesn't really change anything. And then I would take the inverse cosine of 0, and that's going to give me 3 theta. So I think about what angles give me a cosine of 0. And I would get, if I think about my OIO chart, I was thinking about it in my head, I would get pi over 2, or 3 pi over 2, and so whatever, plus pi in, if you wanted to say this, is equal to 3 theta. And then I just have to divide all of those pieces by 3. So I know that my petal is going to begin at pi over 6, which is something that we saw, because we saw that it was 0 at pi over 6, the radius was 0. And then every pi over 3 later is going to be another part. So if I added pi over 3 to pi over 6 and found a common denominator, I would find pi over 2. So this is when the petals begin and end, when n is an integer. Okay, I hope that helps out with graphing polar equations, and I will see you tomorrow.